JEE Advanced 2021, Paper 1, Question 13. Physics, Angular Momentum and Torque. Let us visualize the setup for Question 13. We have a particle of mass 0.2 kilograms initially at rest at the point -10, -1 in the xy plane. At time t equals 0, it is accelerated with a constant acceleration of 10 meters per second squared along the positive x direction. The origin is marked here, and we need to analyze the angular momentum and torque of this particle with respect to the origin. Here is the question. A particle of mass 0.2 kilograms starts from rest at the point -10, -1. It accelerates at 10 meters per second squared along the positive x direction. K hat equals I hat cross J hat. Which of the following statements are correct? Option A, the particle arrives at 10, -1 at time t equals 2 seconds. Option B, torque equals to K hat when it passes through 10, -1. Option C, angular momentum equals 4 K hat at 10, -1. Option D, torque equals K hat at 0, -1. The key concepts here are the cross product formulas for torque and angular momentum. Torque equals R cross F, and angular momentum equals R cross P, which is R cross M. We remember the cross product rules. I hat cross I hat is 0, J hat cross I hat is minus K hat, I hat cross J hat is K hat, and J hat cross J hat is 0. These are essential for computing the direction of torque and angular momentum. Step 1. Let us verify option A. The x-coordinate as a function of time is x equals -L plus half at squared, which is -10 plus 5t squared. The y-coordinate stays constant at -1 since there is no y acceleration. At x equals L equals 10, we get 10 equals -10 plus 5t squared. Solving, 5t squared equals 20, so t squared equals 4, giving t equals 2 seconds. Option A is correct. Step 2. Let us calculate the torque. The force is F equals ma I hat equals 0.2 times 10, which is 2 I hat newtons. The position vector is R equals x I hat minus J hat, since y is always -1. Torque equals R cross F equals x I hat minus J hat cross 2 I hat. Expanding, 2x times I hat cross I hat, minus 2 times J hat cross I hat. I hat cross I hat is 0. J hat cross I hat is minus K hat. So torque equals -2 times minus K hat, which is 2 K hat. Notice that the torque is independent of x. It is always 2 K hat. So option B is correct, but option D, which claims torque equals K hat, is incorrect. Step 3. Now the angular momentum at the point L, -h. At t equals 2 seconds, the velocity is Vx equals at equals 20 meters per second. The momentum is P equals 0.2 times 20 I hat, which is 4 I hat. The position vector at 10, -1 is R equals 10 I hat minus J hat. L equals R cross P equals 10 I hat minus J hat cross 4 I hat. Expanding, 40 times I hat cross I hat minus 4 times J hat cross I hat. Again, I hat cross I hat is 0, and J hat cross I hat is minus K hat. So L equals -4 times minus K hat, which is 4 K hat. Option C is correct. Step 4. Let us verify why option D is incorrect. We showed that torque equals to K hat always, regardless of the x position. This is because the y component of the position vector is constant at -1, and only the J hat cross I hat term contributes to the torque. So at x equals 0, -h, the torque is still to K hat, not K hat. Therefore option D is wrong. The answer is options A, B, and C are all correct. A. The particle reaches L, -h at t equals 2 seconds. B. Torque is to K hat, which is constant everywhere along the path. C. Angular momentum is 4 K hat at the point L, -h. D is incorrect because the torque is to K hat, not K hat. Exam tips for JEE Advanced. Tip 1. When the force is purely along the x-axis, only the y component of the position vector contributes to the torque. That is why the torque here is constant. Tip 2. Remember J hat cross I hat equals minus K hat, so the minus sign gives a positive K hat direction. Tip 3. Constant torque does not mean constant angular momentum. Here L grows linearly with time as velocity increases. Tip 4. In multi-correct questions, verify each option independently. Remember these key formulas: torque equals R cross F, angular momentum equals R cross mv, and torque equals dL by dt. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.